Hi there. For this video, we'll be discussing how to multiply radicals. So let's go on immediately to an example. Let's have square root of 2 times square root of 3. Now the key in multiplying radicals is to simply multiply the radicand inside. So we'll have here square root of 2 times 3, or when simplified, this is simply square root of 6, and that is the answer. So that is how we multiply radicals. So we'll try to use this idea in the next examples. So let's have 3 square root of 12 times square root of 6. For this one, observe that we have radicals out here and we have a number out here without a radical. So what we do with this number that doesn't have a radical is we just leave it alone. So we can write this one as 3 times, multiply the radicand inside, so that will be 12 times 6. And from here, instead of immediately solving for this one, what we can do is we try to factor these two numbers into their simplest forms. So we'll have 3 times the square root of 12 is equal to 2 squared times 3. Since 2 squared is equal to 4, so 4 times 3 is 12. Then 6 is equal to 2 times 3. And from here, note that this one is equal to 3 times the square root of 2 squared times 3 times 3 is 3 squared times 2. So from here, observe that we have a perfect square out here and a perfect square out here. So we can extract that out to this radical. So we'll have out here 3 times 2 squared outside the radical is 2, and 3 squared outside the radical is 3. And the one left inside is square root of 2. So let's move this one. And so simplifying this, we have 3 times 2 times 3 is simply 18, and square root of 2. So, and this one out here is our final answer. So this is a good tip in multiplying radicals, that when we encounter this one, instead of immediately multiplying it, what we can do is we can try to factor it out, so we can cancel out some of the terms in the radicand and extract it out instead of multiplying it at first. Because what if we have like 25 times 16? So that will be a very large number. But this one is just equal to, let's remove this to avoid confusion. 25 times 16 is just equal to 5 squared times 4 squared. So it would save some time in solving that radical. Let's have this third example. Let's have the cube root of 9ab squared times the cube root of 3b. So again, we multiply the radicand inside each. So we have the cube root of 9ab squared times 3b. And again from here, let's try to simplify. Try to simplify some things. So we got the cube root of, note that 9 is equal to 3 squared. Then we got 3 squared times 3. That will give us 3 cubed times a out here. Since there are no a's out here, just write this one out. Times, for the b, we have a b squared here and a b here. So b squared times b is b cubed. And from here, since we have a 3 cube out here and a b cube out here, we can extract that one out of the radical. So we'll have here 3 times b square root of a. Or when simplified, this is 3b squared of a. And this one out here is the answer. So this is a nice example wherein we try to involve variables in multiplying radicals. Let's have this next one. Let's have square root of 2 times 12 minus square root of 3. For this one, note that we'll now try to apply the idea in binomials. So if we treat this expression as a polynomial, what we do is we distribute this one out here. So this one will become square root of 2 times 12 minus square root of 2 times square root of 3. Since this one is a radical and this one is a whole number, we can't really simplify this anymore. So we'll just have here 12 square root of 2. But for this other one, since these two are radicals, what we do is we multiply the radical inside. So that's 2 times 3 or 6. So we'll have here minus square root of 6. And that is the answer. Let's have this next one. Let's have 2 plus square root of x times 3 plus square root of x. From here, what can you notice? These are binomials. And do you recall how we multiply binomials? We apply the FOIL method. So to illustrate that one, FOIL method stands for first. We got F stands for first, so multiply the first term. So 2 times 3, that will give us 6. Multiply the outer terms. So 2 times square root of x, that will give us 2 square root of x plus, multiply the inner term, so that's 3 times square root of x. So that will give us 3 square root of x. And for the last term, multiply the last term square root of x and square root of x out here. So that will give us square root of x times x. Simplifying, we'll have here copy the 6. So this one is 6. Then recall in adding radicals, when we have the same radical out here, what we do is we add the coefficients. So this one will become 2 plus 3 square root of x. And this one, the last term, is square root of x. So this one will become 6 plus 5 square root of x, and the square root of x squared is simply x. And this one out here is the answer. So as you can notice, the concept of multiplying radicals can coincide in how polynomials work. Now, so far, our examples are only radicals that are similar or has the same index. What if we have square root of 2 times the cube root of 2? Note that we can just multiply this immediately since we have different indices. So the strategy that we will use in solving this one is to try and make the indices same. So how do we do that? Well, note that square root of 2, we can write this as 2 raised to 1/2 times 2 raised to 1/3. And recall that in fractions, if we have dissimilar fractions, what we can do is we can multiply 3/3 out here and 2/2 out here to make the denominator same. So we'll have here 2 raised to 3/6 times 2 raised to 2/6. So when this one returns to its radical form, it will become the 6th root of 2 cubed times the 6th root of 2 squared. So now observe here that the indices are now the same. So we can now multiply the expression inside the radical. So this one is simply equal to the 6th root of 2 cubed times 2 squared. Adding the exponents, we'll have the 6th root of 2 raised to 5, or simply the 6th root of 32. And that is the answer. So that is how we multiply radicals with different indices. So let's have this one last example that is similar to that one a while ago. So we'll have the cube root of x cubed y times the 6th root of xy squared. Now here, note that before we apply that technique, note that we can actually extract x first out here to simplify the process later. Since we have x cubed out here and we have a 3, an index of 3, this one is equal to x cube root of y times 6 root of x y squared. So basically, we extracted x from the radical. And from here, we apply the method that we did in the previous example. So we write this one as x times y raised to 1/3 times xy squared raised to 1/6. And from here, what do we need to multiply? In this one and in this one. Again, our goal is to make the denominator same. Since 6 out here, that 6 is equal to 3 times 2, then we know that what we need to multiply here is a denominator of 2. To make this still the same radical, we multiply 2 in the numerator as well. So that this one out here is equal to 1. So it's just like an identity. So this one becomes x times y raised to 2/6 times xy squared raised to 1 over 6 still. So let's clear out some space. And so going back to our radical, we'll have x times the 6th root of y squared times the 6th root of xy squared. So we can now multiply the radicand inside. So this one will become x times the 6th root of y squared times x times y squared. When simplified, this one is equal to x 6th root of, observe that inside the radicand, or the radical rather, the radicand out here, we can't really extract anything anymore out the radical since x has an exponent of 1. And then y squared times y squared is equal to squared times y squared is equal to y raised to 4. So 4 is still less than the index 6. So we can conclude that the expression out here remains the same. So we'll have x times y raised to 4. And this one actually is already the simplified form of this problem. Now before I end this video, here's an exercise, 2 exercises that you can work on. So let's write that one up. Exercises. So we have first, we have the square root of 15 mn cubed times the square root of 45 m squared n p cubed, that one. And the second is the square root of 3a times the cube root of 2a squared b squared. So basically, in the first example, we'll simply just multiply the radicand inside and simplify it, since the indices are same. But for the second example, since we have different indices, let's move this one out here. Your goal is to first make the indices same and then apply the same method in the first one. So these are the 2 exercises that you can work on to improve your skills in multiplying radicals. So that's it for this video. Please don't hesitate to comment down below your solutions, your answers to these exercises, and as well as any other comments and suggestions and recommendations that you have for our future videos in this channel. So that's it, and that's all for this video.